Okay, so I'm gonna put this one there, and this one there, and I'll put the consumables here, and I'll put this one here. So we have every single type of item that we support right here. I'm gonna watch my console. There we go. So if I press E, you see it spawns a meteor. This is my meteor sword. If I use this one, it doesn't spawn anything because it's just a standard sword. This one should spawn bees, and it does. It spawns bees. This one should just be eaten because it's an apple. It's a consumable. Welcome back everyone to another episode in our inventory tutorial series. So in the last episode we got the hotbar working, which is very nice. We can see that our hotbar works, and we can also scroll to select different items. The item we select is also saved, so we can access all its properties and anything else we have on it as well. So today what I really want to focus on is actually using items. Heading straight to our code, there's a few things I want to change. Now at the moment we're using abstract functions for all of this, and every single time we have to inherit it and write the same functions every single time we create something that is an item. That's a bit annoying. I don't want to do that every time, and so I'm going to replace this with a virtual class. Virtual classes are a little bit more different. First thing I'm going to do is change this from an abstract class to just a normal class. Cool, that's going to give us errors for this. Now, these are now not going to be public abstract item class anymore. These are going to be public virtual. Cool. That's still going to give us an error because now it wants it to be now it wants us to provide it a actual something to do. Abstract classes we don't have to define. We just have to say, yo, there's this function here. We don't know what it's going to do, but a virtual class says there's a function. It's going to do this, but instead it can do something else. And you'll see how that comes into play in just a sec as well. So let's define this class. Now this is quite simple. We're just going to say public virtual class item class get item, return this. By default, it's just going to return the default item. By default, our get tool should return null because by default we don't have a tool. By default, miscellaneous should also return null. And by default, get consumable can also return null. Now let's also mark these as virtual. Fantastic. Now if I'm just going to open up my assembly here as well, just so I can see all my scripts. Cool. Now I'm going to head over to our consumable class. Now here we have the overrides. Now here's what's cool. We don't actually have to include any of these. We just have to include get consumable, which is going to return this because it's overriding this. So by default, when we say get consumable class, it's going to do this, which is going to return null. However, our consumable class is going to override that action using obviously the override keyword, and it's instead going to return this being the consumable class, which inherits from item class. Because it inherits, we have access to all of these. This is going to make a little bit more sense as well once we move into the using function, which we're going to add after I set this up. Perfect. So that's set up. I'm going to do the same thing over to our miscellaneous class. So I'm just going to get rid of get consumable and I'm going to get rid of those as well. That's it. Cool. And same for tool. I just need to keep get tool. The rest of these can go away. Fantastic. Now you might be thinking, what about get item? Don't we have to return this for get item as well? Not necessarily. By default, get item is going to return this. So if I have a tool class and I say get item, it's going to do this. By default, it exists. If I am obtaining a tool class as a tool class, since it inherits from item class, we still have access to all these public virtuals, public virtual voids, or whatever type they return. So yeah. Now when it comes to actually consuming the items or like using them, there's a few ways we could have done this. So in our inventory manager, I'm just going to collapse all of that. That's all good. Now what I'm going to do is I'm just going to bind, since I don't have a player controller or anything, what I'm really quick going to do is create one. So, you know, most of you guys will already have your player set up. I don't, since this is just an empty project for me with just the inventory. So I'm just going to create a dummy player with the dummy player script. So I'm just going to right click, go create empty. This is my amazing player. We can just press reset on that. Cool. And I'm just going to create a new C# script. Call this player controller. Fantastic. I'm going to drag and drop that onto can't add script. I don't care. Add it, please. Beautiful. Let me open this up, and all this is going to do Yeah, you can reload. All this is going to do is just manage my input for my player, so I don't need that, and I don't need start method either. That's fine. Cool. So, however, I will need a reference to my inventory, so I'm just going to say public inventory manager inventory. That's it. I can set that in the inspector. Now, I just need a key, so when I press a key, it does consume the item or does whatever that item needs to do. What I'm going to say is if input dot get key down, key code dot e. I'm just going to bind it to, that doesn't matter for now. And here we're going to actually consume the item or use the item. And we need to define the item, obviously. The item we're going to use is going to be in our inventory manager, the selected item. So that is this one here. We're going to say, yo, get the selected item and use it. To use it, we need to define a function. Now, what we could say is say, you know, if item is this, if item is equal to, you know, whatever class we want. Let's say if item is equal to sword, then, you know, hit, else continue forever until our code becomes spaghetti, and no one likes that. So what a better method to do would just say, whatever item we're holding, just use it. Whatever it's meant to do it. So to do something like that, we're going to create another virtual method, which is going to be public virtual void, because this is going to do something, doesn't return anything, called use. And we want to pass in the player controller. So player controller caller. I like to keep a reference of the player controller who called it. This way that if the use function has anything to do with the player, we can at least have a direct reference to it. Now by default, I'm just going to say debug.log use the item. So now my player controller, let's add some functionality. I'm going to say inventory.selectedItem.use. And the player controller it asks for, I'm just going to pass in this because this is a player controller. And that's it. Now we're using the item. So if I head back into Unity, it's going to ask me for an inventory manager. I can just select the one in my scene on inventory. There you go. Save. Get my console ready because we're going to start logging some stuff, and I'll stop maximize on play as well. Press play. Cool. So now I'm just going to put my sword in my first inventory slot and press E. And you'll see it says used item. Now, what if I put my apple there, press E, used item again, it increased by 2. So it doesn't actually matter which item we put into that slot. As long as we call that function, it's going to do the default method because all of our items inherit from item class. So for example, now, however, if I select this empty slot and press E, we'll get a null reference because selected item is not set to anything. So let me just fix that up as well. I want to say if inventory.selectedItem is not equal to null, then use it, just so we can avoid getting that error. And there we go. Now currently, every single time we use an item is just doing the default virtual method here, use, debug.log used item. Now that's good and all, you know, fantastic. We're using items, and in here you can put whatever, you know, default method you want for all your items. Whatever you put in here, however, should be something that all your items, regardless if it's a, you know, a weapon or a tool or a consumable, all of them should do this by default. That's it. So usually I'd put just a debug log statement in here because a lot of my classes are just going to override and do something different anyway. So, you know, it doesn't really matter what you put in here. Just for testing purposes, again, I just put debug. Now, obviously, a consumable item, when we use it, it should subtract that item from our inventory because obviously we use that item, and also maybe add some health to our player or whatever else we want it to do. Whereas a sword, when we use it, it should swing, or, you know, whenever we use a hammer, etc., it should swing. So obviously, everything's going to do something different. Now, miscellaneous class is the most simple one because it's just not going to do anything. So let me just quickly write this up. The same way as we override, we're going to say public override void, and it's going to use. And you'll see it automatically adds base.use and passes in caller, caller being the player controller here. Now what base.use does is it goes to the base class, our base class being this one, item class. So if I right click and say go to definition, It's going to take me here, obviously, and it's going to call use, passing in the caller that it already passed in. So it's just going to do this. Fantastic. That's pretty straightforward, obviously. But what is important to know is this base.use. Sometimes we don't want to do it. Sometimes we do want to do it. It really depends on the type of use case. Now, at the moment, for example, a miscellaneous class, I don't want it to do anything at all. It should be unusable. So I'm just going to comment that out. Done. Now, all this is going to do is literally just an empty function. Nothing is going to happen. Since we're overriding, we're not even going to debug.log anything at all. Nothing is going to appear. And we'll test that later on in the episode because I know it's going to work anyway. So now let's jump over to our tool class. A tool class should also do its own thing. I'm going to say public override void use. There we go. Base.caller. Sure, you can do that. That's fine. Here I also want to debug.log swing tool, because we're not sure what type of tool we're swinging. We're just swinging a tool. Okay, so that's great and all. Let me go and test what we have so far. Okay, so I'm gonna open up my inventory here. Starting items. Let me just add another starting item. And do we have another item class? We have coal, which is a miscellaneous class, as you can see here. So I'm just gonna add 5 coal. That's fine. Now if I press play, there we go, 5 coal. Let me add that into my first slot. I'll add my sword and also add my apple. Now, when I first press E on my apple, it's going to say used item. Fantastic, because we haven't given that an override function. If I select my sword and press E, you see it says swing tool. Fantastic, so it does its own unique thing. If I press E on the coal, nothing happens because a miscellaneous item you shouldn't be able to use. So perfect, it works. Now let's set up the consumables. When I press E, it should obviously give our player some health and subtract that from the inventory. So how do we access all of that information? Well, since we're passing in the caller, it's relatively simple. So let me just add the public override void use player. There we go. You can do the base method, that's fine. I'm just going to debug.log each consumable. Fantastic. And it should subtract 1 from the player's inventory. Our player obviously being caller dot inventory dot remove. And what are we going to remove? Well, we need an item class item. Coincidentally, this is an item. And if I just do that, then realistically, this should also work. Okay, let me put an apple into my first slot. If I press E, each consumable is called. And you'll see it did subtract it. However, it subtracted it from this slot because our remove function calls it directly from the next available slot. That is slightly annoying for us. If I press E again, it's going to start subtracting from this one. What it should do is it should subtract from the selected item slot, which is a bit tougher to do. Now, since we keep track of our selected slot index, we can access the currently selected slot in our hotbar, right? So we can just say selected slot index inside hotbar slots. Sorry, not hotbar slots, that one. Inside items. Yeah, so we'll just get the same way that we refresh the hotbar. So you'll see how that works in a sec. Rather than putting this into a remove function or trying to edit this function, because remove and add do exactly what they're supposed to do, I'm just going to add a new function, public void, and I'm just going to say consume, which takes in a consumable class. Let's call it consumable, that's fine. The number of rows we obtain here, where is it? Hotbar slots items, this one. That same line I'm going to take. We will edit it. Okay, so items I plus that one. No, we want to say items selected slot index plus hotbar slots of length times 3. Remember, times 3 is just the number of rows in your inventory before the hotbar row. Dot get item. Not get item. I just want to say dot sub quantity 1. And someone pointed this out to me in the last in the comment section. There's actually a typo in this. Let me fix that real quick. There we go. Sub quantity 1. Yeah, that should be fine. I don't think I even have to pass this in. Yeah, I shouldn't have to pass that in. I'll just call this consume selected. Or even just use selected, because this use selected could also be applied to blocks, for example, that you place in your inventory. We want to say use selected. It's just going to subtract 1 from the quantity of our selected item. Now, that's not going to work very well here because we're saying inventory.remove. I should be saying inventory.consume. What was it? Use selected. There we go. And that's just its own function anyway. Perfect. So now if I head back into Unity, I press E. It's not currently doing anything. Wait, it is doing something. It's just not updating in our inventory. Let me make sure that I actually have refresh UI in here. So we want to subtract it, and then I want to say refresh UI. There we go. And we call refresh hopper from refresh UI, correct? Yes, we do. Okay, cool. I don't have to call that separately. Nice. So we call refresh UI. That should appear there as well. Sub quantity. I go to definition. Quantity minus equals that. Okay, I want to modify sub quantity. Can I modify sub quantity? How much does it actually depend? So we're going to subtract quantity if quantity is less than or equal to 0, then we want to say quantity equals 0. I should actually have a clear method in here. I do. Okay, cool. I'm just going to clear it. This way that any single time we subtract too much from a slot, then and it says, okay, well, there's no quantity left in here, then just wipe the item. The slot is now empty. That's just going to make that function a little bit more versatile as well. We're all about making everything modular. Okay, so let me put that there. E. Fantastic. Okay. Nothing happens when I try using that. And try using that. And no errors when I try using that. That's it. We can now use items. Now, someone also asked me, what about, specific items? So, for example, I have a sword. For example, that bee sword in Terraria where you hit it and it spawns bees. Let's say I have a sword that I want to do that. I hit something and it should spawn something else, for example. For that, you're going to need to create another class. So I'm just going to create a C# script and I'll call this, for example, I'm going to call it a bee sword then. Why not? In fact, it should be called bee sword class. That is probably a better way of calling this. Sometimes it's better to create classes inside from Visual Studio itself because Unity is a bit slow. This should be called bee sword class. There we go. Model behavior. No, this is going to inherit from type tool class. Nice. That was perfect. Okay, so obviously these don't exist anymore. Now tool class, we don't have to inherit anything unique. What I do need to say is I'm going to copy that. And I'm going to move this down into tool/tool. Because our bee sword is going to be inside of this. So let me find it. Bee sword class. There we go. Perfect. And this is going to be tool/bee sword. And remember, this is just an example. So this is to show you guys how inheritance and stuff works in programming. So let me say get tool is going to stay the same. That's going to use it from this one. But the only thing we're going to override is use. Cool. So it's going to say base.use caller. Now, what is base.use? Well, if I right click on base and say go to definition, it takes us to tool class, because obviously we inherit this one from tool class. So it's going to say base.use, which is going to go to this method and do this. So it's going to debug.log swing tool, as well as go to this one's base and debug.log use item. So if I use a B sword, it's going to say swing weapon and used item, but it should also do its own thing. So I'm just going to debug.log B sword time. Now, what I said earlier was you want to make sure that your original override functions. So for the B sword, it's this one. It needs to be unique for all sword types. It needs to be the same for all sword types. So for example, if I have another sword which spawns a meteorite instead, then I don't want to call this every single time because it just doesn't make sense. So I'm going to comment now base.use because we don't want to do the default action. We want to completely override that and do our own action. And it's going to be B sword time, and maybe, we'll instantiate an object. So how do I instantiate an object? Because instantiate, for example, it doesn't work. Does it work? Apparently works. This should probably say object or instantiate though. Shouldn't it? Yeah, it should be object or instantiate. Weird. Okay. Well, let me set up this B sword, for example. So I'll have a game object that it spawns. And I'll just call this B object. And it can just instantiate the B object at vector3.0. There can be no transform.parent. That's fine. I'll just say quaternion.identity. Again, this is just for testing purposes. Apparently, it doesn't need object. That's interesting. Yeah, that's fine. Okay. Well, let me call it and actually caller.transform.position. Okay. So what is this going to do? Well, it's going to debug.log B sword time, and then it's going to spawn the B object that we specify at the player's position. And that's it. So let me create a B sword. So if I go to items, now our sword might break, or maybe not. Actually, it should break. Yeah, that's fine. I can create a item tool. Under tool, I can just create a default tool, which is just a default tool, or I can create a item tool, a B sword. Because I didn't put public here, that would make sense. I was going to say there's a field missing here. Okay, and you can see that our default tool class or a sword doesn't have that field, but our B sword class obviously does. So let me just set the parameters up for this. I'm just going to create a empty object. I'll call this B. This doesn't need anything on it. Put it there. That's fine. Again, testing purposes. Will survive for now. I'll just call this B sword. Call this B sword. You can have the item icon of, let's give it just a golden sword icon. Is stackable? No, it's a type of weapon. B object is going to be my B. Cool. Done. Let me make sure that it gets added to our inventory start items. There we go, put that there, make this one. Fantastic. Okay, now that's all set up. A lot of you guys will already have this information for your games anyway. It's just to show you guys how it works. I have to create it as well. So I'm going to press play, and now when we use our B sword, it should spawn a B. Now seen. So let me put that there. And you can see it creates a B clone each time that we press E. Whereas a normal sword doesn't do that. Fantastic. It works. I was pressing E then as well. I don't know if you can hear it. I don't know how loud I can press, but yeah, so it works. So each different type of sword, which is unique, does its own thing. You'll see if I press clear and if I press E on this, it does the usual swing tool behavior, right? Which means that the default sword action for all swords is going to be swing. But then this one will also spawn bees. Now, what if I say, okay, every sword is going to swing. So, in here we've already said tool class swing tool. We want our B sword to obviously swing as well. Well, then in this time, in that case, we'll say, okay, swing the sword, but at the same time, instantiate the B object, right? So we don't have to obviously debug.log this as well. And what this means is that you can do the default behavior and the override behavior. It just depends on each sort of type. And if you wanted to have a sword which spawns meteorites instead, then you can create another sword class. Or what I would personally do is to have, instead of B sword class specific to B sword, I'll have a spawn sword class, for example, and every sword which is going to spawn an object at the same time that it swings is going to be under the spawn sword class, right? And here we'll just define the spawn object instead, right? And then that would be in here. So I'll just say spawn sword, right? And then I'll call this spawn sword class. And I'll rename this here as well so it actually works. Okay, fantastic. Now that means instead of creating a new class for every B and every meteorite sword and every flame sword or whatnot, if a sword's going to spawn something that as we swing it, then just do this. Just use this class. So let me clear the console and just edit my B sword item again. Clear that and go to B sword. Spawn object for this one is going to be a B. Let me also create one, let's say for meteorite. Meteor. I can't spell, that's fine. I couldn't care less at the moment. Spelling wise, we'll survive. Let me create another item, tool, spawn sword, and we'll just call this meteor. And here it's going to spawn a meteor. I definitely spelled that wrong. Meteor swords. I have no idea how to spell that. There we go. Sprite can just be, we'll give it a mace. Why not? It's a weapon. Cool. Let me add that to my inventory, to my start items. Add one. Cool. Let me maximize this time. Actually, I can't maximize because I actually need to look at the side here. Okay, so I'm going to put this one there, and this one there. And I'll put the consumables here, and I'll put this one here. So every single type of item that we support right here. And I'll watch my console. There we go. So if I press E, you see it spawns a meteor. This is my meteor sword. If I use this one, it doesn't spawn anything because it's just a standard sword. This one should spawn bees, and it does. It spawns bees. This one should just be eaten because it's an apple. It's a consumable. And you can see that we consume it. Eventually it goes. And this is just the miscellaneous item. So when I press E, it shouldn't do anything at all. There we go. And that's how you define unique abilities for each of your items, unique methods, using very simple, compact code, and very modular as well. So that's it. A bit more of a technical tutorial today because it is quite a hard concept to grasp initially, but I hope it did make sense for everyone, and I hope it's gonna be useful for everyone. That said, I will catch you guys in the next video, where we will hopefully do crafting. Until next time, take care and peace.